What are fully online people doing?
Fully online people
Yeah.
for virtual or for map tests?
Yeah.
Map tests, you guys will be taking your map tests Monday, but with Mrs. Constantine. So I'm going to put a link up there for you. Good question. All virtual kids will be taking their map test Monday with Mrs. Constantine, and there'll be a link on my website or on Schoology. So what'll end up happening is everybody will come here. Okay, I'll take attendance, and then I'll tell you where you're going. All right, so let's look at number 4. Number 4, this is a review of yesterday. First thing I want to do is combine my m's. 6m minus 5m, or 6m minus m is 5m. Now, I distribute the 5, 6. So 5 times 6 is 30, divided by 6 is 5, so I have 5m. 5 times 10 is 50, divided by 6, well, I don't know what that is. So I'm going to leave it as 50 over 6. Now I want all my variables to one side, so I'm going to go ahead and subtract 5m. And notice I'm going to get 0 equals negative 50 over 6. And this is no bueno, so there's no solution. Number 5. On the left-hand side, I have 10k plus 7. On the right-hand side, I'm going to write the k's in front. I'm going to have negative 10k minus 3. So I'm going to go ahead and add 10k because that's smaller. That's going to give me 20k plus 7 equals negative 3. Minus 7 gives you 20k equals negative 10. Divide by 20. K equals negative 1/2. All right, ready, Chucky? A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. Okay? So let's go ahead and draw a picture. Okay, so you got this boat. Chucky, you drawing this? All right, good. This boat is going upstream for 4 hours. The return trip only takes 2.8 hours. Because the boat travels 3 miles per hour faster downstream than upstream, so upstream it's traveling at X miles per hour, and downstream it's traveling at X plus 3 miles per hour. Now it says, how far does the boat travel upstream? Wow. It's a tough one, right? Now, here's the question. Let's say I'm going up here to Port Louis, right? From Port Chucky. So we're leaving Port Chucky and we're going up to Port Louis, okay? Isn't that the same distance as going from Port Louis to Port Chucky? Same distance, right? It doesn't matter if you're going upstream or downstream, correct? So going upstream, all right? So let's think about this. The distance is the same. So upstream. The rate is X miles per hour, and the time is 4 hours. Downstream. distance equals rate, which is x plus 3, and it took me 2.8 hours. But you already told me these two are the same. So 4x must equal x plus 3 times 2.8. So let's go ahead and distribute this. So that's 4x equals 2.8x. Now 3 times 2.8 is 8.4. You can check me. I could be wrong. Now, how would I go about solving that? Minus, not 8.4, 2.8, because you want everything to one side. So let's go ahead and subtract 2.8x from both sides. Those cancel. You're left with 1.2x equals 8.4. So x equals, what does x equal? And he's like, nope, lost.
I lost you a while ago.
I know.
So
7. All right, Annie. I'll fill you in. So we're going upstream and downstream, right? The distance upstream from Port Chucky to Port Louis is the same distance as Port Louis to Port Chucky, right? It doesn't matter, right? Upstream, downstream, it's the same distance. So in the problem, it says, okay, it takes 4 hours to go from Port Chucky to Port Louis, and you're going at X miles per hour. It doesn't tell us how fast we're going. We're just going at X miles per hour, okay? Now going downstream, we have the current, so we're going to move faster, right? So it's saying right here, the boat travels 3 miles per hour faster. So that was X going upstream. So X plus 3 is going downstream, right? It says it only took us 2.8 miles, or 2.8 hours, right? So the blue, this work is right there. So distance equals rate times time, so we just did rate, which is x, times 4. That gave us 4 hours. Now going downstream, the rate is x plus 3, and the time is 2.8. So I just did that. Then I distributed that throughout, and I got 4x on this side, I did nothing, equals 2.8x plus 2.8 times 3 is 8.4. And then I just got all the x's by itself, and I got x equals 7. But Louis, it asks what? How far, right? So my rate is 7, and I want to know how far. Well, I need to know, well, I'm going at 7 miles per hour upstream, right? And I went for 4 hours. So it's 28 miles. Good girl. Starting to mark kids opposite when they get. Tyler. You okay? It's a good problem. So we're going to skip number 2 because number 2 is the same as number 1, right? Same problem. So I don't need to do number 2. A passenger on a plane makes a trip to Las Vegas and back. That was me. I went to Vegas. On the trip there, it flew 432 miles per hour. It's actually how fast planes fly. And on the return trip, it went 480 miles per hour. That's because they get something called tailwinds, all right? Because of the jet streams, all right? When you fly east to west, you fly into the wind, It's like running on the back side of the track, okay? And running on the near side of the track, you get the wind at your back, so you run a little faster. All right? But the jet streams go from west to east, so you go quicker. How long did it take the trip there, or how long did the trip there take if the return trip took 9 hours? Well, guess what? This is pretty much the same problem we just did, right? So here we go. We know, right? Let's think about flying there. On the trip there, we flew at 432 miles per hour. But we don't know how long we were flying for.
Well, where is it flying?
You don't know. But that's a great question, because if you knew it, you could Google it, right? All right? And then it says on the return trip, we were going 480 miles per hour, and it took us 9 hours. Right? And we know the distances have to be the same, because we're going there and back. So how would I solve this? Well, 432 times x is 432x. And then we can do it quicker. What's 9 times 480? You mean that number? Yeah, human copies. So now we go ahead and we divide by 432. Do you know what that is? There, Mr. Gallo? Hey, come on, you got a calculator, I don't. How am I doing this quicker than you? So it took 10 hours. So you're able to get back in like 9/10 of the time. All right, we're good. Number 4. And number 5. No. I like this one. All right, we only skipped those 2 because we don't need to. This one is a great question, right? Why am I telling you this? Well, the fall's here, right? And let's be honest. I know he's not here, but Mike's going to have to make some money, right? So Mike's going to want to make some money, and he's going to want to rake some leaves, okay? And Tyler wants to make some money, but he also doesn't want to do that much work. He's like, yo, maybe I can work with Mike. You know, 2 people raking a yard is quicker than 1 person raking a yard. So here we go. Shauna can pour a large concrete driveway in 6 hours. Dan can pour the same driveway in 7 hours. Find how long it would take them both to work together. All right, same thing. If you're raking a yard, right? If you rake it, it takes you 6 hours. If Mike rakes it, it takes him 7 hours. Okay? How long would it take both of you to rake? Well, now you know your answer has got to be less than 6 hours. Why? Because it took Tyler 6 hours to rake it by himself. So if you're having somebody help, should take less, depending on your help, should take less than 6 hours. Okay, so here we go. How do we do this problem? Any ideas? Guess what? It's this. Distance equals rate times time. So let's look at this. You want numbers? No, we're getting there. So for Shauna, okay, the distance, you got to think a little differently though. The distance for Shauna is 1 driveway. So she's going to concrete 1 driveway. We don't know how quickly she does it. Okay, But it does take her 6 hours. How would I solve that for R? 1 equals 6R. How would I solve that for R?
-6.
Not minus 6.
I'll divide.
Divide by 6. So we have our rate for Shauna is 1/6 of a driveway. Dan. Towards one driveway, but he does it in 7 hours.
Divide by 7.
Divide by 7. All right, here's the thing. Watch this. Ready? Now, if they work together, we have one driveway, and they're both working together. Shauna works at a rate of 1/6. Dan works at a rate of 1/7. And we're looking at how long would it take them. Now, what's 1/6 plus 1/7 there, Louis?
19. Or well, 1. Wait. I didn't feel like getting the common denominator.
Why not?
Like, I would have to use 6 times 7.
You're breaking my heart. Elton John and Kiki D once sang, "Don't go breaking my heart."
Being an artist in like the 60s, 70s.
That's like saying, weren't you a student in like the 2020s?
Wait.
So, as Louis said, common denominator is 42. So 7 over 7 would be 7 over 42 plus 6 over 42, that's 13 over 42. So, we can multiply it by 42 over 13. So get rid of that. And we're left with T equals, you know, what's 42 divided by 13? Come on. Use your phone. 3 hours. Come on, wait. Come on. Is it? Yeah. No. But yeah, you're close. I was thinking 52. You almost told me. Not 3.5.
3.6.
No, use your phone. Do 42 divided by 13. You're gonna get 3.28.
3.23.
3.23. So 0.23 of an hour is what? So do 0.23 times 60. What do you got? Like 13 minutes? 14 minutes. So we take Dan and Shauna 3 hours and 14 minutes to concrete the whole thing. These are the good problems. These are the problems I live for. I love these problems, Patrick. What? Who's Patrick? You're Patrick. I can't. Unreal. All right, number 7's the same type. We don't have to do 8. Oh, let's do 9. 9 looks fun. All right, number 9. Max left the Science Museum and drove south. Science music. This guy's driving south. All right? That's Max. Gabriella left 3 hours later. And driving 42 kilometers an hour faster in an effort to catch him. So I'm drawing the picture. Pretty good, right?
Right.
After 2 hours, you're at the same spot. Yeah, maybe. Maybe. It's a good picture though. After 2 hours, they're at the same spot. Find Max's average speed. Well, guess what? What formula do you think I'm going to use? Yeah, D equals RT. So we have Max over here. Max is going to be red. So we're going to use D equals RT. They both went the same distance, right? So let's figure this out. So Max, how fast was he going? Do we know?
42 kilometers.
Do we know how fast Max was going?
No.
So I'm going to use X, right? How long has Max been driving? It's not 3 hours. Not 2.
4.
Nope. Yeah, why would it be 5 hours? Well, Gabrielle left 3 hours after Max.
1 hour.
No, look, Gabrielle left 3 hours after Max, and they've been driving together for 2 hours. So after 2 hours of her driving, okay,
Oh,
so 2 hours and 3 hours is 5 hours. Now, how long has Gabriella been driving?
2.
2.
We don't know.
How fast is Gabriella driving? Well, Gabriella is driving 42 kilometers faster. She's speeding. So, look, I have 5x, Louis, equals, distribute that in, 84 plus 2x, subtract 2x, I get 3x equals 84, divide by 3, and we got x equals what? 20. Did I get it? 28
Alright.
kilometers per hour. All right, we're not going to do number 10. And I think we're going to call that a day.